Hello everyone. Today we are going to see a program for sorting an array in ascending order. So the programming is with 8086. So the software we are going to use here is going to be EMU8086. So the installation and the procedure for programming with 8086 is uploaded in previous video, and the same link has been given in the description. You can able to see that for your further doubts. So first you have to create an array in the memory space, and after that you have to sort it in ascending order. That is our primary objective of today's laboratory. So here assume that I am going to take 5 inputs, an array element of 5 inputs. So it is going to be 8 bits. So if it is going to be 03, so it can be represented in terms of your microprocessor as 0000, and this can be represented as 8421 combination, so 0011. So total 8 bits. So I am trying to sort 8-bit numbers. So first, in microprocessor perspective, we have to move all those values to memory first, and after that we have to move those values into register. Then we can able to sort those elements with ascending order. So first, assume that I'm going to take 5 elements. So input number we can able to give it as 5. So if you want to sort it as like normal C programming, we have to sort it in the fashion. So first I have to push these values to some of your registers. So assume that it can be AL or BL, whatever it can be. We can able to push those values inside. So we can able to push the value of 03 inside AL and 01 inside BL. And after that you have to compare both the things. After comparing, you have to conclude which one is going to be greater one. After comparison, if it is not going to be a fruitful way in ascending order, we have to shift it, so that you have to exchange the values between, or in other words, we can able to swap those values, and we can able to swap the values in the memory location. So assume that the memory location of this uh, value is at 2000, and this is at 2001, and this is at 2002, and this is at 2003, and this is at 2004. Just for understanding. So I have to move these values here using your indirect register addressing mode, and after that we have to take those values inside those registers, and after moving into register we have to put those values, and after that we have to check which one is greater. If swapping is needed, you have to swap it. If it is not needed, you have to leave it as such. So in this manner, so first we have to check it with 03 and 01. Here the swapping is needed, so the values should be like 01, 03, and other memory locations have to be in the same place. So after that I have to take these two values, and after that I have to check which one is greater. So here it needs swapping, so I have to compare it. If it needs swapping, I have to swap it. So it is going to be 02, it is going to be 03, and after that one I have to check these two values, 04, these two values, and after that I have to move those values correspondingly, and I have to put it. So here it does not need swapping. If it needs swapping, I have to swap it. So like the same, I have to move it for all the elements. So if it needs, like if the elements are going to be, it can be a hexadecimal number, so it can be CC, it can be 01, it can be 15, it can be 0B, all those elements can be here. So in usual sorting, what we will do, we will swap these elements, check for condition. If it needs swapping, we have to swap it, else we don't have to swap it. So like this, we have to swap it for 5 different times. So this swapping, which is going to be swapping all those elements moving inside your register, it needs 5 movements of your elements, and after that, after completing one cycle, we have to swap like the same for 5 more times. So like this you will be doing in your C programming. In the same way we have to do it here also. So first, how we can able to think those things in microprocessor perspective. So first we have to convert this logic into steps, and after that those steps can be converted into programs. First, I am just trying to convert those things into steps. So I am trying to declare two things as inner loop and outer loop. So inner loop is going to check for the transition between 1, 2, 3, 4, 5, and outer loop, after completing this transition we have to move 5 more times. This jump from element to element, we are having 5 jumps here. So this is going to be your inner loop and this is going to be your outer loop. I have taken it like that. So this inner loop and outer loop has to be executed. First inner loop has to be executed, and after that the outer loop has to be executed. So one by one it has to operate itself, so that finally all the array elements will be sorted in ascending order. So here I have to make it as an first I have to declare the count for inner loop and outer loop. So here I am going to take the elements as 0, 5. So my inner loop and outer loop elements will be 0, 5. So after that one, so count of your inner loop and outer loop will be 0, 5. And after that one, so I am dealing all those things with memory, right? So I am having 2000. In that specific value of memory location of 2000, I am having the value of 03. So I have to take this value first. So I have to tell where exactly my array is located. So this is offset address and this is data segment address. So you will see that while you are doing in your programming. This is data segment address, this is offset address. Both in terms of your programming, you have to give only offset address. So this offset address, which is going to be the starting address of the elements, has to be declared, and after that it has to be moved in some registers, and it has to be keep it ready for your further processing. And after that, move first elements to your registers, which is going to be as like you are moving your 03 and 05 to your AL and BL registers. So I have to move it. So I have to compare both the elements. If needed, swap it, else do nothing. So in this one, we have to check for the next elements, memory elements, and after that you have to decrement the loop one by one, so that we can able to have an conclusion like I have repeated the loop 5 times because I have declared the inner loop and outer loop count as 0, 5. So at every stage it has to decrement itself like 0, 5, and after that next loop it is next iteration is going to be 0, 3, 0, 2, 0, 1. So till it finds 0, 0, the loop has to be executed, and after that time, if it's complete, it has to move to the outer loop. In outer loop also, it has to check for 0, 5. The loop has to be repeated multiple times, and it has to stop its execution. So till it becomes 0, the outer loop has to execute, and we have to end this program. Like the way these are the steps we can able to say for checking those values and converting into your micro program or program in your processor. So while you are seeing your EMU8086, so this is how we can able to program it. This is one of the logic. We can able to try with different logics also for doing this program. So first I have to move. We have to declare my outer loop and inner loop. So this is my outer loop and this is my inner loop. Both the values should be 0, 5 since I am taking the array values to be 0, 5. And the values of my array is going to start from the memory location of 2000. So I am putting those 2000 inside my SI, which is going to be a source index. And after that, I am pushing those values into AL and SI plus 1 to BL, which means in previous case, as like we have moved your 03 and 01, right? In the same way, this 03 and 01 has to be pushed into registers. In the same way, I am trying to push those things into registers. And after that, while you are using your 8086, I am having a command compare. So this instruction, what it will do, so it is going to compare your source and destination. So if you are going to compare your source and destination, compare. So first it is going to be your destination, and after that it is going to be your source. So in this case, it is going to compare your AL and BL. So if AL is equal to BL, so your instruction after executing this instruction, your carry flag will be 0. So in this case, how we can able to check it. So after this one, if AL is going to be less than BL, so in terms of your ascending order, so if this is less, since it is ascending order, so the carry should not be generated. That is the case we want it, right? So if carry exists, we don't have to swap. If carry does not exist, we have to swap. So if carry exists, so in this case, if this carry exists, so it doesn't need any swapping. So which says that if carry is going to be 1. So if it finds this carry to be 1, it will not swap. So if AL is greater than BL, now it needs swapping. So your C is equal to 0, right? This is the case we have to follow for our ascending order. So this is carry flag. So I have to check the carry flag each and every time after comparing the operations. So this is going to be my carry flag. So I have to check it. So if the carry flag is set, it has to move to miss. Here it has to move, which means I don't have to swap it. So as like in your C programming, while you are doing it, will be if you want to swap A and B, so you will assign your value of A to T, and after that you will push the value of B inside A, and after that we will push the value of T to the value of B. So we will be having a temporary variable, right? In the same way, I am going to do the operation. So I am going to use this operation of Si plus 1, which is actually the value of B. So I am pushing into DL register, which is also an 8-bit register. So after that one, I am using an exchange instruction. What is the purpose of this instruction? So if you are having A and B, it will try to swap the values in A and B. So after exchanging, I can able to move this temporary variable or the memory location from DL to this specific memory location. So this is just for swapping those elements of A and B. In specific, in the memory locations of Si and Si plus 1. So which is like the memory location start from 2000, right? From 2000 and 2001. So if I want to swap it, so Si value is going to be your 2000. So Si plus 1 is going to be your 2001. So this values has to be swapped in the specific memory location. If it needs to be swapped, we have to use these 3 instructions. And after that, I have to increment my Si. Why I'm just trying to increment my Si? Because in the inner loop for next iteration, so it is 2001, and after that is 2002, right? So in this, the values of 2001, which means like it is 03 and 01, right? So after swapping these two values, I have to swap these two values. So the value of Si previously it is 2000. So I have to jump to 2001 so that Si will be 2000 and Si plus 1 will be 2002. So for that I have to increment my Si, and after that decrement my CL, so that I have to understand my CL inner loop has been completed one time, and after that it will check for its jump no 0. So till this CL is getting 0, this loop will be iterated, so it will jump to loop 1, so that these operations will be performed without disturbance, right? So it is going to be 2003 and this is going to be 2004. This value is getting completed. So all the 5 elements being completed, so that inner loop is completed. So when the inner loop is getting completed, your CL register will be equal to 0. When it finds this CL register equal to 0, so while you are checking jump no 0, it has to check for the condition whether your 0 flag is set with the help of your CL register. So this CL register, it's try to identify whether it is becoming 0. So when it finds it 0, it will jump to the next location, so that it is coming to the outer loop. So outer loop has been executed once, so I have to decrement my CH. So outer loop I have to decrement from 05 to 04. So and after that till this CH value is getting 0, So I have to jump to this memory location because the CL value first initially it will be from starting from 05. After that, it is going to be moved to 04, 03, 02, 01, 00, right? So when it finds 00, it is pushing it to some other loop. So, but now the CL register value has been changed, but it will not try to again. It will not try to move from 05. So I have to again initialize my CL to be 05, and after that I have to declare my starting address of my memory location as 2000, so that it will start again swapping from 2000, and after that is going to execute the loop again and again till it's getting completed. So after that one, till its CH value is getting 0, the loop will be executed. After it's becoming 0, we can able to halt the program. So we can able to see how these values are getting changed and swapped. So this is the overall procedure for making a program for sorting an array in ascending order. So we can directly move to the programming section. So in programming section, so I can able to, I have already made the program in EMU8086. So the same program. So here I have declared the same loop 0505 SI to be 2000H. It's capital H. Okay. There is no problem. It can be capital H or small h. So 2000H, and after that all the programs in the same fashion. So now I have to give the elements, right? First I have to give the elements. So if I want to give the elements, so I have to emulate. After emulating it, so I can able to keep all these things ready. This is emulation, and after that I have to take with my values of my memory. So I have to check with my memory, and after that I have to take with my flag conditions also, so that I can able to check for my flag status. So these are the things which is needed, so we can able to check it one by one. So in this case, I have to declare my values at 2000, right? So the values should be starting from 2000. So I can able to change the value exact location to 2000. So there I can able to enter 5 values which need to be sorted. So it can be of 0f. So it can be having any random values. So it can be starting from 02, 05, 01, and 03. 5 digits I have entered. So the count is going to be keep on incrementing whenever it's completing. So I can update it. So we can able to see here this data segment which is going to be starting from 0100. So it is going to be data segment, and after that memory location starts from offset address, which is going to be 2000. So 2000 is having those values. So when I'm trying to execute it one by one, so CH is going to be 05. That is the first instruction which is getting completed, and after that CL will be 05 again. So this is getting completed, and after that one we can able to move to the next instruction. So we can able to see your values one by one, so that SI register is getting the value of 2000. So SI is getting the value of 2000. Here I think it will be clear. Yeah. So SI will be getting the value of 2000. After that, the value of SI has to be moved to AL. So value of SI is 2000, right? In 2000 we are having 0F. This 0F has to be moved inside your AL. So lower bits of your accumulator register. So if I am moving, yeah, I got 0F here, and after that I have to run again, so that I can able to move to the next instruction. So at that point of time, SI plus 1 has to be moved to BL register. Yeah, 02 has been moved to my BL register. That is also completed, and after that I have to compare my AL and BL whether it needs swapping or not. So when I am trying to do this one, so it is trying to compare it, and it is trying to say what are the things we can able to have here. So it is going to uh, jump no 0. So if this is going to be hit or a miss, we have to check that one. Then we can able to move to the next instruction. Yeah. So it is incrementing its SI, and after that it is incrementing. Okay, sorry. Actually, the program should be jump carry. Sorry for this. So I can able to do it again. Yeah. So I can able to give the values here. FF 05, 02, 01, 03. Sorry. Yeah. So I can able to run it in the same way. I can able to check those values also, whether AL got the value and BL got the value, and after that it is going to check for its condition. So the condition is going to be satisfied or not. So the condition is not satisfied, so it will try to in terms, which means the carry does not exist. So if the carry does not exist, so it will move to this one. So it is trying to move the swapping operation. So now see the value of DL. DL got the value of 0.5, and after that DL has been swapped to the value of FF, and after that you can able to see BL and AL getting swapped with each other. So I can able to swap it, and after that I can able to decrement it. So this has been swapped. I can able to see here, right? These two things are getting swapped, and after that I have to increment my SI so that it can able to move to the next instruction, and after that I have to decrement my CL, and like this way it has to complete its loop again and again. It has to complete it and has to identify its own way to sort it. So like this I can able to move step by step, and I can able to see each and every step. One change is going to happen, and after that at finally I can able to move those values one by one. Yeah, you can able to see the values are getting changed, right? So like this, for every step it will try to update itself with the ascending order fashion with the help of inner loop and outer loop. So I can directly run it and I can able to see how it is getting done. So it starts with 0 0, 0 1, 0 2, 0 3, 0 5 FF. So I can able to take those values and I can able to sort it and I can able to give it to the specific location whichever I want. So like this I can able to set some values and I can able to sort it in the ascending order. So here I can able to increase the count of elements. If the array is going to be having more number of counts, I can able to increment it here. If I wanted to be in terms of 16-bit elements, I can able to make use of 16-bit registers and small changes here, so that I can able to do that operation for 16-bit array and in terms of 16-bit ascending order operation. So after completing this, you just type this program in your MASM 8086 and put it in chat box so that we can able to have and glance like who are the persons who have got it correctly done and doing the same thing in the fashion whichever we want. So this is for 8-bit operation. Convert it into 16-bit operation and put it in chat. Thank you for your patient listening for